may seem obvious that in-orbit refueling is crucial to Starship. If Starship can't refuel in orbit, it can't get out of Earth orbit. But let's stipulate that all the technical problems of in-orbit refueling, like floating blobs of fuel in a near-empty tank and other such issues, can be solved. What else could go wrong? If it turns out that Starship isn't as cheap and efficient as claimed, the cost of in-orbit refueling could very easily doom the project. Let's start with a baseline. The current most cost-effective vehicle to take freight to orbit is Falcon 9. It costs about $27 million per launch and can carry 22 tons to low Earth orbit. The Starship upper stage carries about 1,200 tons of fuel. So, with zero loss of fuel to boil off or inefficient transfer, it would take 55 Falcon 9 launches to fill up a Starship for adventures beyond Earth orbit. Those 55 launches would cost about $1.5 billion, excluding the cost of the fuel itself. Never mind, it would take months to complete that operation, so Falcon 9 is not a realistic option, even as a backup plan. That means the only economical way to refuel Starship is Starship. If Starship meets two important goals, payload to low Earth orbit and cost per launch, it works. If it can't meet those goals, there's no backup plan. The whole thing no longer makes sense. Since we don't know the exact numbers, we have to pick a range. For cost per launch, $5 million is the number straight out of Elon's K-hole, while $20 million is a more realistic estimate. And we'll see how a miss on costs would affect our numbers by stipulating a $50 million worst case, which is generous, since a true worst case would be that refueling launches are expendable. Payload per Starship to low Earth orbit is supposed to be 100 to 150 tons, but it might be as low as 50 tons. Now we can calculate a worst-case outcome. If payload is a disappointing 50 tons and a launch costs $50 million, it will take 24 launches at a cost of $1.2 billion, not counting having to build a large fleet of refueling rockets. How about the optimistic case? At $5 million per launch and 150 tons payload, you can refuel a Starship with 8 launches and a mere $40 million. Holy sensitivity analysis, Batman. What do those optimistic numbers depend on? Raptor engines cost about $2 million apiece, again, optimistically at this stage of their development, and the goal is to get the price down below $1 million. But it's reasonable to say each Starship has $80 million worth of engines on it. That means that $5 million per launch is very highly dependent on needing to do very little to a Starship and booster, other than refuel it before launching it again. In other words, it depends on actually achieving rapid reusability without any glitches or snags. Even a cost of $20 million per launch depends on reusing all the 39 Raptor engines multiple times without refurbishment. Combine this launch cost with the mid-range of payload estimates at 100 tons, and it takes 12 launches costing $240 million. That already starts to look dubious.